So let's start with the first three parts of question 9, the first three integrals. Okay. 9a is simply another case of the derivative of the inside, the inner function sitting on the outside. All right, so the derivative of the inner function is 6x, and here we have x over here. We're just missing the 6. All right, so we could put, let's say, u equal to 3x squared. We could do it like that. Du is equal to 6x dx. And there we have 1/6 du is equal to dx. So let's do our substitution for, x dx. Don't forget that x over there. Okay, so we have x dx in our integrand right there, x dx, and we'll substitute 1/6 du. So we'll put the 1/6 on the outside. Okay, and for x dx we're writing du. And sine 3x squared we're putting sine u. All right, the derivative of cosine is minus sine, so this would be 1/6 times minus cosine u. And now just substitute back u equal to 3x squared. All right, let's look at B. Okay, this is also another case of the derivative of the inner function. Let's rewrite this so that we see an inner function more clearly. The inner function is sine x. So the derivative of sine x is right there, cosine x. So if we put u equal to sine x, we have du in our integral cosine x dx. All right, so now we're ready to substitute, and we turn this into a simple power function and use our power rule. And now you just substitute back for u. You substitute back sine x. And that would be your final answer. Okay, so let's go on. Let's look at C now. C is a simple case of the derivative of the denominator sitting in the numerator without a minus sign. So this is going to be a log. All right, so let's look at that. In fact, what we're doing here is we're putting u equal to the denominator, the entire denominator, 1 plus cos x. And so du is minus sine x dx. So minus du is sine x dx, which is what we have. So doing our substitution, I'll put the negative on the outside. We have minus du for sine x dx and u in the denominator. So this is a simple log. Don't forget the minus sign in front, and I'll let you substitute back u equal to 1 plus cosine x. For 9D, we use the trig identity, sine squared x plus cos squared x is equal to 1. So 1 minus sine squared x is equal to cos squared x. So we'll do that. We'll substitute cos squared x underneath the square root, and we do that just so that way the square root pops off. We have the square root of cos squared, so we just get cosine x. which is equal to sine x. The derivative of sine x is cosine x. Okay, we're going to do E with another trig identity. We have the identity tan squared x plus 1 is equal to secant squared x. So secant squared x minus 1, that's equal to tangent x. So we'll use that substitution again, getting a perfect square underneath the square root, which is what we wanted. So the square root pops off, and now we just have to integrate tangent x. Now remember how to integrate that. You write tangent as sine x, another identity, another trig identity. Tangent x is sine x over cosine x. And this turns into a log because the derivative of cosine is minus sine. So this, put that minus over there. So we have minus log cos x plus c. Okay, and that finishes number 9. Okay, see, we're not quite finished with number 9. We have a few more integrals to do. Okay, so let's look at f. All right, so here we have tan squared x over secant x. Now we know we have that identity involving tangent and secant, so we can try that. Okay, so we have tan squared plus 1 is equal to secant squared. So tan squared is secant squared x minus 1. So now we have 2 terms in the numerator and only 1 term in the denominator. When we have only 1 term in the denominator, sometimes we can divide and split up the integral. All right, and in this case, that would give us something that we can integrate. Okay, here, do the division this way, and we get secant x. And do the division this way, and we have 1 over secant x. Now remember, secant is the reciprocal of cosine, so that would be 1 over secant is cosine. And we have 2 things that we can integrate. Now, how do we integrate secant x? Well, we remember that one we saw once, and we just remember it at this point. Once you see it once, you remember that the derivative of secant is ln secant x plus tangent x. And the derivative of cosine is the integral of cosine is sine. The derivative of sine is cosine. So this one is just sine. All right, let's go on to G. All right, well, we just did that. We know that that is equal to ln. Again, we just remember this. This is one that you just commit to memory after you've seen it one time. Okay. And tangent, we actually did that in a previous integral. We said the way to integrate tangent is to rewrite it as sine over cosine. And then you have to realize that you have a log integral. Derivative of cosine is minus sine, so that would be minus ln of the denominator. Okay, 2 more integrals. 9I. When we look at this combination, we should immediately say to ourselves, well, the derivative of tangent is secant squared. So what I have here is I have secant squared x dx. And so I have a derivative here, and here I have the function whose derivative is secant squared, that is tangent. I have tangent x to the 5th. So a simple u substitution, u equal to tan x, would convert this into u to the fifth. All right, we would do the power rule there. Okay, so here we have u to the fifth, and that's du. This is all du. Whoops, I put a u there. Let me change that to x. Okay, now it's du. Power rule, u to the 6 over 6. And then just, instead of u, substitute in tangent x. All right, J, we have the integral of secant x, sine squared x dx. Now we should remember when we integrate sine squared or cos squared, we use what we call the half angle formulas. All right, and here's the one for sine squared. Sine squared x is equal to 1/2 1 minus cos 2x. It's called the half angle formula because this angle x is half of this angle 2x. All right, so let's do that substitution, and we have, let's put the 1/2 on the outside. So here we have 1 minus cos 2x dx. And we can integrate each term. The integral of 1 is x, and we know that the integral of cosine is sine. All right, so let's see, let's do that. So we have 1/2, here we have x. Okay, the derivative of sine 2x is cosine 2x times 2. Now since we're missing that 2, we compensate with a 1/2. And if you want, you can just differentiate this and make sure you get cos 2x. Okay, the derivative of sine 2x is cos 2x times 2 times a half gives us cos 2x, so that's good. That's correct. Okay, so now I think we really are finished with number 9.